All right, hello everybody. Yeah, good morning. I think I got everything up here. Let's go ahead and get started. So some announcements. See, hand in homework number 4 due tomorrow. And then after that, there's no hand in homework due next week because you'll be doing like review stuff. Non-graded review stuff. And the lab, not this Thursday, but the next Thursday after that is a review lab. So it's an optional lab. Online homework. We've got chapter 6 is due tonight at 11:59 p.m. That's that extra online homework that's snuck in here just to get to work out so we could get all the way through chapter 7 here. The chapter 7 is posted and that's due on this Monday, the next Monday, 11:59 p.m. I also got the syncing to work out with the grades for Pearson. So if that didn't work out, just email me and I'll try to get it fixed. But that's not an automatic sync. So I actually have to literally push a button in Moodle and it'll sync all the grades over. So don't expect it to immediately jump over to Moodle and get your grades over there. All right. Tomorrow, bring your calculator. So you'll be doing some linear regression. So you'll have to type some data in there and your calculator will get that figured out for you. First exam, October 3rd. That's next Thursday, 6 p.m. to 7:30 p.m. in this room. Don't schedule anything if you haven't already. So if you may have a conflict, contact me and we can figure that out. Yeah, let me know by Friday. That'd be great. All right, for the test, you may bring a calculator, of course. That's a non-QWERTY calculator. It's a non-keyboard. So you shouldn't be typing emails or stuff like that with your calculator. So no cell phones. And their formulas, I did post a practice test on Moodle, so you can see what formulas you'll have for this test. Reminder, there's a study jam. It meets tonight and every Monday and Wednesday in Lomason 271. The review sheet I haven't gotten up yet. That's just like a list of things that you should review. I'll get that up here in a couple days. Exam preparation. So study jam on Monday. Review session. I'm going to figure out a time. It'll probably be in the evening on Tuesday. Just a quick poll here. How many people would be interested in going to a review session on Tuesday? All right, so I'll get a big room. So we can all fit in there. I'll try to find a space for us. Study jam on Wednesday night. That's 6:30 to 9 p.m. All right, any questions with what's going on? What you need to do? No. So the question was, does the exam makeup have to be on the same day? And no, it does not. And we'll schedule a date. So it'll probably be like the Monday afterwards, I think, is what it's shaping up to be. So any other questions? All right. Okay, so I had a question about how to do the how to get the right Well, on the homework. So on the homework, you had this. It was like 1B or something like that. You had to get a frequency table. So you go stat tables, frequency table. And then we were interested in the heights. But then, so you had to find like a mean plus or minus 1 standard deviation. So the easiest way to do this is just to use the between formula. So we're doing it at the height variable. And let's say we are doing between, well, you'd actually calculate this out. I don't remember what they were. But you do between plus or minus 1 standard deviation and then plus or minus 2. And it says, oh, okay, we're binning it. Okay, that's cool. But then this is the number you want. It's the count. So that gives you the count between these two numbers for the height variable. All right, any questions with that? Did that answer? I forget. I don't see where you are. Did that answer your question? Oh, what was your question about? Oh, yeah. Oh. Oh, okay. Yeah. Yeah. Okay. I'll do this one too. Yeah. Yeah. This so summary stats correlation. And we want to do two. See, like if you just click it doesn't work. But if you hold the control button, so you're holding the control key, and then you can click two guys, like any of these. You can unclick them, click them. Yeah, with control. So, all right. And then you could just do all of them, so you can see all of them. So, of course, that's a different data set, but you can pick as many as you like. Yeah, and you could maybe there's a way just to copy paste it all, like highlight and control C that. But you could also just type it over, just transcribe it. Any other questions? All right, so let's get into, we were talking about linear regression. So we're on page 91. All right, so what we're doing is we're minimizing the residuals. Just a little refresher with the residuals. That was like let's look down here real quick with what a residual is. So like, for example, you've got this guy is a residual. It's the observed minus the predicted. So remember the hat was predicted. I didn't mean to do that dot there. All right. And that's the distance, the vertical distance, because with the y variable. All right, so that's residual. It's often used in E to say what that is. All right, let's look back at here. So we want to minimize the squares. So we're minimizing both the vertical, the dots that are above, the positive ones, with the positive residuals, and we're minimizing the negative residuals as well. That's why we need to do the squares, so that the negatives become positive. So, all right. So the formula is the sum of the residuals, so these E's, which are the sum of the differences between observed minus the predicted, squared. Those are squares. And then, so that's what the calculator is doing and the computers are doing when they get this linear regression, is they're just minimizing that value. All right, so let's look at the how to find that the equation of the line. So remember that, that we've got the formula. Oh, let's see, what was it? It was y hat equals b sub 0 plus b sub 1 x. Right there, that's the equation of the line. Kind of looks familiar. Maybe you could see like y equals mx plus b in there. We use some different letters. All right, and then you can find you find b1 first, and then you find b0. So you use b1 to find b0. So this is a lot of work to do by hand, but just so you know how it's done and where it's coming from, we should look at this. So these are the standard deviations. Again, this R, that's the correlation coefficient, which had that big formula several pages back that we learned. It's a lot of work there, but yeah, let's just do it once. So yeah, let's do that on the next page. Right there. All right, so we've got x bar, y bar, standard deviation of x, standard deviation y, and r value. So we've got b1 was r times s sub y over s sub x. That was what the formula in that box on the other page. And then we do a little bit of a scavenger hunt here. R is 0.9298. And then S sub y was up here. It's 11.386 years. I write the units down so you can see what the units are for B1. And S sub x is 4.832 inches. So then when you calculate that out, you get 2.191 years per inches. That's the units on that. All right, any questions with that? It's pretty straightforward as long as you have that formula there, just what's going on. And then B0, we recall that it's y bar minus B1 times x bar. And again, we do the scavenger hunt. Y bar was 21.407 years minus B1. We just found B1 was 2.191 years per inch. And then x bar is 4.832 inches. So the inches cancel with as far as what happens with the units right there. And then we're just left with years. Oh, did I not do x bar? Oh, yeah, I wrote the wrong number. This is x bar in spirit. Okay, 10.185 inches. And they still cancel out. Thanks for catching that, whoever yelled that. Yeah, so now it looks right. So you calculate that out, and it's negative 0.908 years. All right. And then we have to put those two things together to get the equation of the least square line. So it was y hat, just recalling again, it's b0 plus b1x times x, that is. And then so here we've got b0 was negative 0.908. And then plus b1 was 2.191 times x. Okay. So there you go. And then you could also be asked how to write this in the context of the problem. What that is searching for is just for you to use some words instead of x's and y's. So what that would mean is the y variable was about the tree age, the age in years. So tree age in years. So we put a really large hat on that one. And then we say equals negative 0.908 plus 2.191. And the x variable in words was tree diameter. In inches. So I'm just going to put a nice little box over this. You'll see this again. All right. Ominously. Just going to write that. So yeah, being able to write the equation in the context of the problem. It's kind of like confusing what that's asking for, but this is what it's asking for. So you have the words in the equation explaining what the variables are. Any questions with that? You'll get some. Maybe we could just jump over to the practice test real quick and I could show you. You do this? Oh, finish this? Oh, finish the, yeah, let's finish the problem and then I could jump over if you guys are still curious. Okay, here, what is the predicted age for a tree? 15 inches in diameter. So this is just a little bit of good old-fashioned algebra. Can everybody see that? Tree age, years. 2.191. And then the 15 goes right in where the tree diameter went. Right there. Type that in your calculator. You should get 31.957 years. And that's a prediction. I think that's finished with that. Well, no, let's finish the problem. I think there's more to this. Let's go to the next one. So here we've got the slope coefficient, like interpreting what the slope means. So I'm just gonna box this one. Oh, question? Oh, where? Hey. Diagrams. Oh, a formula list? Yeah, there will be a formula list. Not every single formula ever will be on there. It's just kind of like a bare bones thing. Oh, are you asking what, like if it'll be in each of the problems or at the end? Some of them will be. So I'll show you, I guess I'll show you right now since you're really interested. Let's just look at it. It's on Moodle. Let's go there. Well, caps. So you'll want to be a student. There's an exam resources section. So the practice exam will be posted on October 1st, 8 a.m. So you'll have time to look at those answers. If you look at the practice exam on the end, here's what you got. So you got the z-score, you've got what the r value is, you've got the linear equation, how to find B1 and B0. You've got what an average is, the sample average. You've got the standard deviation formula. You've got what range is, what IQR is. You've got normal CDF. You've got inverse norm, and that's all you got. So if you want more formulas, you'll have to memorize them. So you'll have to, yeah, no note cards or anything. All right. Any other questions? So yeah, just look it through this multiple choice. Some nice boxes to fill in. So you got everything here. All right, so let's get back. Oh, a question in the back. Hey. A Scantron? No Scantron required. Yeah, so you'll just write on the test. You'll have to write like sentences sometimes because it's statistics. But yeah, with the multiple choice, you'll just circle the answer. All right, so the slope coefficient of 2.191 years per inch means that the predicted, so that's an important thing, predicted age of a tree increases by 2.191 years. Second thing, and then for every additional inch. So those are three parts to that interpretation of the slope. So that's a prediction, how much it's increasing by, and then every additional unit, every additional what. All right. And then down here, it's just saying, yeah, what I just said there, what you should include. So the second thing is the intercept. So the intercept of negative 0.908 represents the predicted age for a tree having a diameter of 0 inches. So again, there's units, and the only thing here is that it's at 0 when the x variable is 0, and then what would happen to the y variable. So, question? A slope coefficient? Yeah, we have. So that's actually the same as saying a slope, and that's it's B1. So it's a coefficient because it's right next to the x variable. And anything that's next to something else, you can call a coefficient. So, right. So let's just go to the next page. So back to residuals. So we've got residual equals observed minus predicted. Something you might want to memorize because you need to know what a residual is. You could also kind of rearrange the symbols a little bit and write it like this if you wanted to. It's totally okay. So this is saying that you could think, this is like saying what the second form is about. So you can think of an observed value as having two parts, as the predicted and the residual. And then we want small residuals for a good model. So that just means that your model, the curve or the line that you're drawing, is close to all of the points if you've got a low residuals. And then residuals can be positive or negative. The positive ones, so this is the positive ones, are above the line. And you could also say that that means under predicted. So that line is the prediction line. It's where all your predictions are. And if the data values are above, that means that the predictions are below, under predicted. Or you could have negative residuals, which just means they're below the line. And those ones are over predicted. So you guessed too high. So yeah, if you see, if a question's asking about like, is this an over prediction or under prediction? Just think about where the line is and where the data point is relative to the line. It's above or below. So, okay. All right, so we've got some missing values here on this. So here we've got a table. It's got all these, it counted off the observations. We've got all of the diameters in inches. We've got the ages in years. And then this one is the predicted age in years based off of this, off of that equation up there. And then we've got the residuals. All right, so for this one, let's just work down here. We need to find, we've got a couple blanks here. So let's just work down here. Well, there you go. Actually, all right, so we've got tree age in years. So the predicted tree age in years is equal to negative 0.908 plus 2.191. And then we just stick the diameter right here, the 2.2. We stick that into the function right there. And you can oh, hi, question. Oh yeah, that's just a trifling difference. It's just a little bit off. So -1/2. No, it's fine. It's fine. So there's no conceptual error there. It's just when they did it, it came out differently. So, yeah, maybe it's a rounding issue. What more likely is that how many decimal places they used in the data itself. So when you're finding those values. So this would give you 3.912 years. And that would go under the predicted years spot. And then the residual is we want to take the observed minus the predicted. So E is equal to, the observed was 8 minus the predicted was 3.912. And then that would give you 4.088. And then that would go up here. All right. So something to note is that the sum of the residuals is always 0. So that has to do with how we found that line. So we found that line so that it would minimize the residuals, and that always happens when the residuals add up to 0, all of them. So it's in the midst of all of those points, so to speak. It doesn't necessarily go right through the points, but it's got well, we could even do a thing where you would count how many points are above and below, and you'd think that half of the points would be above, half would be below, right? That's what you would think. Possibly. Let's just do it. Can we? Yeah, let's do this on the next page. So we can have something like a residual plot. So here, we've got one plot that's the original scatter plot. Oh yeah, if you really want that, I should go back because there's a blank that we didn't fill in that would probably, like, some of you really want to fill in. All right. So there was a blank. All it is, it's 37.812, and it's -4.812 right there. If you want that. I don't think we ever use that again. So yeah, let's go back to this. All right, so here's the residuals. So this is how far off we are. So we're either +2, -2, -4. And then if you count them, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 up above. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 3, 4, 5, 6, 12. Well, it looks like there's not, it's not exactly in the middle because of some outliers. Or not outliers, but values that are accounting for more. 5, 6, 7, 8. Yeah, so you can't count on there being the same number of dots as above or below. All right. Yeah. Well, where would I count that one? Above or below? Neither. Maybe we could throw it to the below one just so that it kind of equals it out a little bit. But it's if you're to talk about it, you just say it is right on there. So you wouldn't lump it to either way. All right. Any questions with that? I mean, it was a good idea, right? You'd think like, oh, maybe there's the same number of dots on both sides. But they still do add up to 0. So that's the main thing, main takeaway here. Right? How would you interpret the residual plot for the tree age and diameter model? So we would say that the residual plot displays mostly random scatter. Mostly random scatter. Indicating, so that's a good thing. So indicating the linear model is appropriate for predicting tree age from tree diameter. So if you see random scatter, that means there's no pattern that you missed. So we'll look at some more residual plots here and see what some other ones might look like. So the reasons why we like residual plots are it's easier to compare the sizes of the residuals. And then also it's easier to detect patterns right there. So here we've got 2 of the scatter plots with the linear regression plotted. And then here we've got the residuals. So it's easy to see that you've got something like that going on with that one. And same here, you've got a pattern right there. So V-shaped pattern in residuals indicates linear model is not appropriate. And then down here, similar thing, clear pattern in the residuals. Indicate linear model is not appropriate. It's not appropriate. How is there not a what? Oh, on the left? Oh yeah, there is a clear pattern. So V-shaped pattern in residuals indicates linear model is not appropriate. So yeah, they both, you would not want to use the linear model for either one of those. Okay. Does that answer that question? So yeah, you're totally correct. So here, we've got some random scatter. So linear model is appropriate. Yeah, let's just leave that up there. And then this next one, well, this is mostly random scatter. So let me just write it down so you know why. Mostly random scatter. All right. This next one is mostly random scatter. But if you look over here, this is also random scatter. So that's not what we wanted. We want a linear pattern. So mostly random scatter, but no relationship in original scatter plot. So you want to be looking at both the residual plot and the original scatter plot to see what's going on there. Right. So here we've got the residual plot. You see they're all clumped together here, and then they kind of fan out like that. That's a bad sign. So that means that you would not want to that the linear model is not appropriate. Fan-shaped pattern indicates linear model is not appropriate. All right. All right, so let's look at the residual standard deviation. All right, so this is just, it's mostly what you'd expect for a standard deviation, but then we have this n-2 on the bottom. And then also something that happens is that the mean of the residuals is always equal to 0, so we can drop that. So this is the simplified version over here. So what this means is it's roughly the average size of the error of the residuals that we'll make if we use the least squares line for the prediction. All right, so for example, with the tree age data, we had this standard deviation for the residuals was 4.275 years. So the units are the same as for the Y and the residuals. It's the same units. So on average, our predictions were off by about 4.275 years. All right. And that would be that would be less than the standard deviation of the age in years. If we look back several pages, it was 11.386, and I think we'll give that up here in a little bit as well. Yeah, on the next page. So yeah, let's talk about this R squared. So it's a new thing. It's not really so new. It just has some nice properties. So all it is the R value is literally squared. So if we had R value of, well, I guess we'll get to that on the next page. There will be an example with that. All right, so this underlined portion is pretty much why R squared is important. It's telling you how well you can predict this data. So, okay, so we have these two sets here on the next page, page 100. So this one, the dots are really close to the model. And then this one, the dots are further away. So this acreage burned versus number of fires, that would be less useful for predicting. So you'd expect a lower R squared value there. And you can look at the residuals as well. This is super informative down here. So here we've got the original data. Oh, question? So it tells you how good you can, how good of a prediction you can make using that model. So how likely is it going to be a good prediction? So the model is referring to that this is a line, a linear model. So it's the shape of that curve that we're drawing in there. But it's telling us how good of predictions we can make using that line. So let's just look at this. Let's look at this down here. So we see that the residuals have a small variation. So with the box plot right there, and this one was good for making predictions. And then this one, the residuals have a large variation. So this was bad for making predictions because we wouldn't know if we're close or not. There's a large variability there. And I think we'll go ahead and end here. We'll start up again with R squared on Friday. See you guys.